Hello everyone, so today we're gonna learn about binary search algorithm. Before I proceed further, I'll just explain what our regular approach is. For example, this is my sorted array and I wanted to search the element 7 in my array. What usually we're gonna do is that just take one for loop and iterate the element one by one. Is array index 0 equal to 7? No. Proceed further until we find out the element we wanted to search. If it is not there as well, we have to iterate the whole array. So the time complexity will be O of n is in this case, because we have to iterate array until n item. N is the total size of the array. What if I will say that we can reduce this n to log n using the binary search algorithm. Isn't this is amazing? So let's see how we gonna reduce this time complexity. First thing is that we have to find out the middle element of the array, and once we find out the middle, what we check if my middle element equal to my search. So in this case, is 7 equal to 5? No. So we check if my search item is lesser than this 5. That means if it is lesser than 5 means 4 or something, then we just have to check on the left hand side. And if it is greater, this case is 7 is greater than 5, so we gonna check that search item on the right hand side. So this is how we have to check the item we want to search, only the half part. Here as well we gonna again apply binary search algorithm on the another half, that is the right half of the array. So again we gonna find out the middle. This is kind of recursive process. That's how we have reduced the complexity of either iterating array until n to log n only, because we just have to check on the half of the array each time recursively. Let's see how. I'll just try to dry run this code. For example, my low is initially 0 because array always start with 0, and my high is the length. What's the length of the array? It is 5. Length minus 1 is the 4. That means that will be the last index, right? So my high is here 4, and I'm gonna find out mid every time until my low is less than or equal to my high. Okay, make sure you follow this condition. Now my mid equal to 4 divided by 2, that is 2. So this is my middle element. I'll check is my search item is equal to first what the condition is, if my mid is equal to the search, then just return that we found the element at array of mid, right? And we can return from here because we found out the answer. If it is not, in this case it is not, so what we gonna check, if my middle is lesser than search. In this case middle element is less than search, right? So what we have to do, we just have to update my low. So my low was previously 0. Now I have to update my low to this half, right? Because my low, what will be? It will be mid plus 1, because element is not at all present on the left hand side. That is finalized now. Now I have to update my low equal to mid plus 1. And if this is also not true, what if the search item is 4, then we gonna check if my middle is greater than my search. If it is that, then what I'm gonna do, I'm gonna move my high to mid minus 1. That means whatever the mid minus 1 will be my high. So here it is mid minus 1. Okay, now another thing, like we were trying to dry run, right? Let's complete that part here. Now my mid equal to 2. Here the 7 is not equal to 5. Now my low gonna be mid plus 1, which is 3, and my high was as it is, which is 4. Now I'm gonna check is my mid, which is 3 plus 4, 7. 7 divided by 2 is 3. Okay, so my middle equal to my search item. Yes, it is, and we gonna return the answer because we found out the search item. So that's how the binary search works. I hope you understand. If you really like the video, do like and subscribe. Thank you.